Okay, this is problem number 2 on homework number 7, and it's a problem from a previous test, and the marking scheme that was used in that test is given here. First of all, notice that it must run, otherwise automatically there's a 35% deduction of the mark. I mean, there's no reason why this should not run, in spite of the fact that you had everything done correctly. It should have run. But anyway, that's not the issue right here. So we have these two pieces which are made of steel, and this pin, this cylinder is inserted into that. In other words, don't get the impression that these two actually are completely uh, bonded together or welded together, or it cannot be assumed that this is a single part that looks like that. Okay, in other words, and another way of saying it is that the connection between the face of this cylinder and the inside hole in this block is contact. Now, however, the end edge of the cylinder and this circular piece, they're perfectly welded together or perfectly bonded together. This end is clamped, and the bottom of this piece is subjected to a pressure, and you're supposed to do the problem. Now, uh, I tried to use surfaces in order to create this problem or to create this block in the homework problem number 1, and I miserably failed. So I'm gonna try to do it again, but this time with a different approach of creating that block. Okay, using splitting with the surfaces. So all right, and by the way, something like that was done in the activity in the same lab, activity 8, problem number 3, and it was done completely differently as far as making that block is concerned. All right, so let's go ahead and we start with the product file, because this is an assembly, and immediately save it, file, save management, save as, homework number or homework 7, problem number 2. And let me go ahead and make the block first. So insert a new part in there. And I'm going to call this thing the block, properties block, and block. Okay, and let's go make it. So double click on this. On that plane, I will sketch a centered rectangle like that. Okay, and we'll draw a circle here. Let's dimension these things. This is 3 inches. This is 3 inches. The radius of this is 1. You see for a second. Radius is 1. Yeah, I have a feeling that when I did homework problem number 1, I inadvertently took to be radius to be 2. But that's no, it's impossible. No, I must. Oh, wait a minute. These are 5 inches. Yeah, this is 5 inches. Okay, sorry. So that's why it looked different. So this is 5, and this is 5, 5, and this diameter is 2. Okay, not 3, 2. Exit. Now I can pad this thing in each direction by 1 inch. I think that's what this thing said. Check it out. Is it? 5 inches. Woo! 2.5 in each direction. Good, good. Now, here's the way I'm going to make this cut that I was thinking. So on this plane, I will sketch. Okay, so I'll sketch something like this. How about just be patient You see what I'm doing here? Okay, let's do a bit of a cleanup. That point, I want it to be coincident to this point. Okay. This point, I want it to be coincident to that point. Or actually, let me make it this edge. Same thing. Okay, good, good. And for example, I can do here, let's look at this thing from the front. Let's do a horizontal line here. Okay, something like that. And do a quick trim. I want to get to this and that and that and that. Exit. And I'm going to make a surface here. So in order to do surfaces, obviously you cannot be in part design. So you have to go to shape, for example, generative shape design, and you take this sketch and extrude it in both directions. Mirror extend in both directions. There, okay, and say okay. Now I want to cut that object with this, okay? Cut that object with this. So, for example, obviously, if you're going to cut a 3D object, a solid, you cannot be in generative shape design. Okay, so you have to switch. You have to switch to uh, part design and get the split. Get the saw right there. Read it carefully. It says splitting element. Splitting element is actually this surface. And it says, do you want to keep the outside or the inside? Now, obviously, I want to keep the outside. So I say, okay. And there we are. So if you hide that, this is your object. Now, you didn't have to do it like this. I've done it 3 different ways, these 3 problems. And yeah, you decide what you want to do. Okay, so let's go to the product and save everything. File, save management, save as. Let's go up, problem number 2, right there. So in that folder, if you look at it, I will have both the product and the block. I do. And in fact, if you turn this thing around, it's your geometry that you want. So, you know, your geometry looks like this actually. You can see that. Yeah, that's fine. So insert the next part, insert a new part in there. Let me call this thing right click cylinder, properties cylinder, cylinder and cylinder. Okay, let's go make it. Double click on this. On that face, I will sketch. Why don't I project that circle? Where's the project? Right there. Project that circle. Okay, you can see that. It's right there. And if you look at the normal direction, this is the normal direction right there. And I can close this thing. Let me hide that block for you so that it doesn't distract you. So for example, center here from this point all the way to that point. Exit and make a path. I believe, where is my block here? Let me see the block. Where did I put it? Let me bring this thing in the front. Yeah, so I want to pat it in that direction by 12 inches. 12 inches, and there we are. So this is our geometry. Now, you have to use as many planes of symmetry. In this particular problem, there's only one plane of symmetry, and just cutting it like that all the way to the end. Okay, so we can do that right now. Let's go to the product. First of all, save everything. Why don't we make it out of metal, out of steel? The whole thing is made out of steel, so metal. I'll put it on the product. So it's going to put it on both parts. And now you're going to get the saw. There's the saw. And read the bottom left corner. It says select the plane that you want to use for cutting purposes. It's this one. And it says, hey, if you cut it with that plane, two parts are affected. Or you want to use both of them? Yes. And it doesn't matter what side I keep. So it's going to look like that. Good. So now we're going to go to generative structure analysis. Let's say hypothetically that I wanted to have a finer mesh around the hole in the block. Okay, so you know how to do that. You go there, it says, okay, I want to use a local size right there, local mesh size. It says, okay, but which one? Well, there are two meshes here, so I want to use the block right there. It says, all right, go pick the piece of that block that you want to have finer mesh. Let me hide that. Let me hide that cylinder and go and select this, and notice that already it refined it based on this number. If it's too small, change it. If it's too big, change it. I'll keep it like that. Let me actually make it 0.2. This other one is for this cylinder that I hid. Okay, good. So let's go ahead and look at our mesh. Ah, right click mesh visualization. There we are. Change the rendering here. There we are. You can see that in the hole of the block, there is a finer mesh because I made it finer, right? I use the local mesh refinement. All right, so let's go ahead and let me turn this thing around so we can see it. Deactivate this mesh. My block is in hiding. Let's bring it, not block, but the cylinder was in hiding. Let's bring it. Okay, why don't we do the first let's do the surface slider, symmetry plane. So this is a symmetry plane, and that is a symmetry plane, and these are the only two. This end is clamped, that end is clamped. Good. The bottom is subject to pressure, 100 psi. Make sure you don't divide this by 2 just because you took half of the model, it's pressure. And now I have to create a connection between the face of the hole and the face of the surface of the cylinder and make that a contact connection. So we get first one, connection between the face or the surface of this cylinder and the face of the hole. So let me hide this, select the now this is going to be contact, contact, face-face connection. There we are, face-face connection. Contact is right here, and it's this connection that you created. You see this connection that you created, this one. Good. Now, if I run this, it will bomb out because there is nothing that prevents the rigid body motion of this block along that pin. So let me bring this thing, or the pin when I say cylinder, that's what I mean. Let's bring it here. There's no friction, there's nothing that stops this thing from sliding up and down. So, but the problem says to avoid that, to avoid this sliding motion, we are assuming that the edge of this and the edge of that are perfectly bonded together or fastened together or welded together. So let's go and create a connection. Let's hide this for a second. First component is this edge. Second component is the edge of the thing that I just hid. So let's bring it in the front. Let me hide that and this edge. And these two, this connection that we just created is fastened right there, fastened. So we can do it from here, or you can select this little dot, it's the same thing, right? whatever it's going, it puts a fastener sign there. But this has nothing to do with fasteners. It has to do with the fact that these are kind of moving together. Oops. Let me put this thing back. There we are. And let's save the analysis. File, save management, analysis, save as. In that folder, it was problem 2 folder. Don't forget that on the exam, you have to give us the product, all the parts that make it. Here, there's 2 parts, and the analysis. All 4 files we need in order to mark. So now let's run it. I'm pretty sure it's going to work. This is just a warning you're used to about the fact that rotations are not solid element degrees of freedom. Okay. I'm not even sure why it actually gives that. So, okay, so there we are. If you can animate it, you can see that. Animate. Good. That looks good. You can do the stress, von Mises stress plot. Change the rendering here to material shading. And if you want to look at the displacement, again, change the rendering to material shading, average ISO. Okay, so there we are. And that takes care of the homework number 2. Okay, problem number 2. Homework number 7, problem number 2.